Hello world, this is your ML enthusiast with another video, and today I would like to talk about a new topic before I go forward with the courses. And this is the last. I know it's been a long time since I last uploaded the video, although I've said every Sunday. There's been a little bit of an slack. So, um, anyways, coming back to the point, what I would like to say is, yeah, before I go forward, what I wanted to do is I sincerely thank everyone who has subscribed to my channel, and I look forward to more subscribers. So please do share and like the channel, and yeah, I mean, like the videos in the channel, and also please do share it across your friends and family so that people can learn. This is a channel which is dedicated to machine learning, and its derivatives, but also a new topic which I want to add, and it's also the title of this video: quantum computing. So I know it's the name is so intimidating at first, but then hear me out. So it's actually an amazing subject if you look into it. I've actually given a little bit of touch here and there. I mean, I wouldn't say much. Actually, the gap which I've given between the courses was spending this time learning about quantum computing, at least the foundations, and I'm still learning. So actually, this quantum computing, what I found is that actually I've got this reference from my friend, and he told me that quantum computing is something that is new and it's an upcoming research, uh, going on, trending research. So uh, I would say it's in like, when I gone into the insights, gone through various blog posts through the net, surfed the entire web, how much ever I can, and I could have done, and in all this time, and what I found about quantum computing very intriguing is that it's very, very easy. Yeah, I'm not kidding. I mean, yeah, of course, the difficulties lie ahead with the mathematics and stuff like that, but then come on, there's no subject without maths, right? So you can't expect that without maths you can do machine learning. So similarly, quantum computing mainly applies on linear algebra. So it's actually a very fun subject, and how do I put this? It is, I feel, or what I think, and I think many of people agree with me, at least the people who are well aware of quantum computing, that it's the next big thing. It's the next revolution of computization. And okay, yeah, computization. I hope that term exists. And what I'm making this video on the go. I have no script. I generally don't keep scripts because of what I think is that keeping scripts generally tends to make the video more formal, and let's be free and express our thoughts just like that. And what I felt is that quantum computing is very, very comprehensive, no doubt, but it's also new and you can explore it. So I thought, why not make an additional series of videos? Of course, the previous series that I mentioned will not be on hold, it will be going on along with quantum computing, a little bit here and there quantum computing. So I'll be adding tidbits, okay, of quantum computing, and make it, like how do I put this, an hybrid quantum classical computing kind of system. So this, and I'll be using machine learning to solve. So for that, there are various sources. I'll go through a few sources right now. Like, I'll just show you Open Edge and Google.com. Oh, wait, I think I'm using Google. Yeah. So there's this Python library called Circ, which is developed by Google themselves, and it's an open source framework for noisy intermediate scale quantum computers. So what does this do? It actually, you are programming quantum computers. So like how you program classical computers, you program quantum computers using this framework, which is pretty exciting. And quantum computers have kind of like uh, you know uh, you can build uh, it's built on like how classical computing is built on bits, that is 0 and 1s. Quantum computers are built on something called qubits, or which is actually an abbreviation of or short term for quantum computing. So if you look at this framework right now, which I'm looking at my screen, it's actually a very very comprehensive framework, and you have a lot of things you can do. You can build circuits, you can devise, you can simulate quantum computers. So this is actually uh, something which is exciting. You can actually imagine, which simulation is nothing but an imagination of what exists into something that which you cannot replicate actually. So I know it's a very complicated way of saying that, but yeah, please understand that this is the most exciting part of Circ, which is simulation, and I'm still learning about the framework. So I look forward to applying it in the machine learning concepts, and also trying to modify the hands-on ML book a little bit using quantum computing. And uh, also there's one more library which is by IBM, I think, which is called Kisskit. So yeah, I guess I spelled it wrong. So Kisskit is an open source software development kit for working with quantum computers at the level of circuits, pulses, algorithms. It provides tools for creating and manipulating quantum programs and running them on prototype quantum devices on IBM Quantum Experience. So there is this IBM actually developed quantum computers, and they give it on cloud for free. Yeah, I'm not joking. For free, actually. So if you go to IBM Quantum Experience, so you can actually see to the most advanced quantum computers available, learn, develop, and run programs for quantum applications and systems. So you can actually develop quantum circuits on an actual quantum computer. Whereas Circ, the thing is that you simulate the quantum computers. So you can run them on quantum computers, which is given by IBM. So that is the advantage. And the best thing about this is you can use Google Colab for that. I hope all of you know Google Colab. You can just go to colab.research.google.com, and it's actually, how to put this, is uh, it's an Python IPython notebook, which is online, and you don't need any hardware like GPUs and TPUs, which is actually given for free in this as using the cloud, and you can use this. So uh, see, Collab or Collaborati allows you to write and execute Python in your browser with zero configuration, access to GPUs free of charge, and you can also share your code among others. So this is, you can collaborate with others for free, and there's also GitHub integrations and so much features. Like, even I don't know much about Google Colab, although I use it regularly. Even there's a lot of for me that I don't know. It's a mystery. Like, there's a lot of features, and you can implement machine learning, data science applications. Like, there are a few examples given here on the introduction to collaboratory page. And so these, why am I telling all of this? Like, what is the point? You say, um, I want to see, I'm an ML enthusiast, and I find technology also as an, I'm enthusiastic about new technologies as well. And if especially I can use machine learning on that technology, then of course I'm not beating it. So, not beating to the bush, but you can actually learn quantum computing right now. I'm an undergraduate student, like I'm doing my third year at IIIT Jabalpur, and I actually I'm very proud of IIIT Jabalpur. It's an amazing college, and uh, I although have a lot of like you people who have already finished their college life might know that it's not easy to finish your college, but because you have to spend a lot of time, and at the same time you have to learn a lot of skills to get jobs and all those kind of stuff. But when it comes to uh, learning, the right time is always now. So there's a three thing words that you need to follow: right thing, right place, and right time. So you have to do the right thing at the right place at the right time. So if you do that, then this is like uh, at your college level, when you're 19, 18 years old, your mind is actually at your peak, and when you think at such stages about such complex tasks, it actually becomes easier. When you grow up, like when you're in the mid 30s, and you start learning something new, your brain actually starts learning slower. So it's not uh, I mean, we all age, and age is because neurons die, that's it, right? So um, I would like to say that try to learn new things when you're young. So live free, live wild, and always keep learning. So this is why I wanted to share that quantum computing is something new, and I want to spread this among people and make sure that this becomes something to be excited. And if you want to learn quantum computing like in a more structured way, I actually found an NPTEL course, which is there are actually two courses in it. If you go to NPTEL, which is actually an online MOOC, so massive online course, something like that. It's an online course platform, and if you search for the course quantum computing, there are two courses. One is that is computer science oriented, and one that is the hardware oriented, that is how do you build a quantum computer. So this is how a quantum computer is built and how it is understood. And whereas coming to this course, this is how you program quantum computers. So both the courses are amazing, and they're free of cost, so you can actually enroll and just go through the course. But yeah, if you want a certificate, you need to go through an exam. All the instructions are available on the website, so I suggest you please go to the website. And other than this, uh, so this is what the video is about, and that's all that I have to share. So I'll put all the links which I've just gone through right now in the description below, so please go through that and you can explore on your own. There's a lot of documentary, and you can actually open source contribute to these uh, libraries that I've just saw, like Kisskit and Circ. And quantum computers are now open source available. Like the hardware is not open source, of course, but the software is open source. Most of the libraries that are available on the net. And Circ and Kisskit are two popular frameworks which are developed by IBM and Google and IBM respectively. And so I look forward to hearing from you guys what you think about quantum computing, and should I not implement quantum computing also a part of the ML series. Thank you for watching, and please subscribe if of course you've come this far. So I I think that you have to subscribe, and uh, like and share. So bye bye, and this is